Okay, so I want to just go back and look at some examples of how we would use double integrals to find areas, bounded areas on the plane. And then what we're going to do after that is we're going to talk about finding the area on the plane and then multiplying it by height to get the volume under a surface. But right now, the integrand is just, dy dx or dx dy. So I've got some regions here, and I want to use double integrals to find the area. And I want to look at a couple of these. I've got these labeled 1, 2, 3, 4. I'm going to do 1 and 3, so I'll be out of order a little bit. So let's just look at this first one. Okay, number 1. So what we're going to have is we're going to have an integral, and we're going to integrate with respect to y, we're going to integrate with respect to x. And the question is, well, which one do we want to do first? Now, let's think about this. Let's suppose that we view the situation this way. Let's suppose we have our double integral, and let's suppose we want to fix x and integrate with respect to y. In other words, let's just suppose we fix an x here, and we look upon this as our stack of rectangles or whatever, right? In other words, remember what we're doing is we're taking all of these little rectangles and adding them up. So here, with this solid line, it doesn't look like a stack of rectangles, but it is, trust me. This is a stack of rectangles, and we're going to add those up. dx dy, delta x delta y times plus delta x delta y and so forth. And we're going to add up all the stack of rectangles here. We're going to get the area of this one, this one, this one, this one, this one. We're going to get the area of all of those, and we're going to do that for each and every x. And in fact, we're going to let the width of these rectangles, the delta x go to 0, the delta y go to 0, and we have our double integrals. Okay? Now, if you look at this, so what I'm going to do is I'm going to let x go from 0 to 5. Okay? See? I start here at 0 and I go to 5. Okay? And for each of those values of x between 0 and 5, I'm going to add up this stack of rectangles starting down here at negative x and going all the way up to 4x minus x squared. See? I'm starting here and going all the way up to here for whatever value for x I choose. So that's the y's. The y's are going to do that. Okay. So here's what I've got. I'm starting down there at that line, and I'm just going to integrate it. I'm going to add up all those things. And that, remember, what an integral does is just an adding machine. It just adds up an infinite number of things. Okay. So there's the integral that there's the double integral. So notice my thinking about this. I'm thinking, okay, I want to be able to just, for any x, I want to be able to have a straight shot from one y to the next. Okay. Now, the way we would evaluate this, of course, is, we've got the 0 to 5, and I integrate with respect to y. So I've got y goes from negative x to 4x minus x squared dx. Okay. Right, see that? So I'm just kind of working my way on the, inside here. So what I get now is I get 0 to 5, and I'm going to get 4x minus x squared minus a negative x. And then I'm integrating with respect to x. Okay, so I'm kind of cramming it in here, trying to make it all fit. But you see, so this, all I've got to do now is integrate this one. I mean, this is a baby integral, right? We know how to do this. This is 5x. So So here's what we've got. We've got 5x, so that's going to be 5 halves x squared minus 1/3 x cubed, and we're going from 0 to 5. Yeah, like that. And that will give us the area that we're looking for. That's the area that region. And what we're doing is we're getting set up, we're finding the area of the base, and then we're going to multiply by the height. Okay. Any questions about that? Now, I transition over to this next one, which I'm calling 3 up here, but so I'm going out of order. But anyway, I want to get the area of that closed region right there. Now, imagine if we said, well, I am just going to always integrate with respect to y first. Well, look at this. Notice how how complicated that can be. If we pick this x, notice we go from here up to here, okay? If we pick this x, we go from the same two curves, but if we get over here, look what we've got. We go from this curve to this curve. In other words, if we integrate with respect to y first, we're going to need two sets of integrals, right? Because on the one hand, we're going from this curve to this curve. But then we transition over from a different curve to, well, a different curve to a different curve. So this would require us to have two separate integrals if we integrate with respect to y first. However, in other words, if we fix x and just integrate with respect to y, it's going to be more complicated than if we do this. What if I fix y? And look at this. Here's our here's our little row of rectangles in there. If we fix y, look what x does. X just strictly goes from this curve to this curve, straight across. One set of double integrals is all we need. So you have to be wise in how you choose your integration. You don't want to just say, well, I'm always going to go dy dx. Sometimes you need to go dx dy. So let's see what this integral would look like, this set of double integrals. First of all, I'm going to fix y, and y is going to go from -3 to 3. Now you got to really keep your head on a swivel here, because you're not integrating, you're integrating with respect to y, so y is not going from 6 to 3. It's going from -3 to 3. So you keep in mind, okay, I'm dealing with the y's. And then I'm going to say, okay, well, what is my integrand going to be? Well, my integrand is going to go from this curve on the left to the curve on the right. And I'm integrating, actually, ooh, look at how I messed up here. I put 2x plus 9. I'm integrating with respect to x. Remember I said we're integrating with respect to x first? So I can't, ooh, I messed up. That's not good. So I'm glad I messed up, because now you can see, okay, I've got y equals -2x plus 9. I need to solve for x. I need this bound to be in terms of x. Okay, so x is equal to y minus 9 divided by -2. Yeah, so y minus 9 divided by -2. There, that's it right there. Now we have it. We have it set up the way we need it. Okay, everybody see that? Okay, that's how, so notice how these are fundamentally different. On the one hand, it's better to integrate with respect to y first. On the other hand, it's better to integrate with respect to x first, because your question is there which one can I fix and then have a straight shot for the other variable? Okay. Now, you can see this next one down here. It's pretty obvious what you need to do. Okay, so if you set this one up, let me do this. I've got this double integral. Okay, and what I'm going to do is I'm I'm going to fix the x. See, so no matter which x I fix, and x is going to go from -1 to 2. No matter which x I fix, my y is going to go from x minus 3 all the way up to 1 over x squared plus 1. Yeah, like that. And notice what I've gotten to where I do is I go to the far left integral first and set that bounds up. In other words, that's the way I think about it. Some people do the first integral and then they decide on the bounds of the second, the outside. But there's what we have. Any questions about that? Now, of course, I didn't work that integral up there, but of course, the way after this, you've just got, your calculus problem. You've got -1 to 2, and this is going to be 1 over x squared plus 1 minus x minus 3 dx. And you notice here, you might think, well, heck, this is what I did in Cal 1. I take the integral of the top minus the bottom. Same thing. But we're training ourselves to use these double integrals because that's what we're going to need later. Okay. This is, and of course, if you go through here, you're going to get arctan x and minus 1/2 x squared plus 3x from -1 to 2. Okay. Any questions about that? Okay. Now so I went through those. Now I want to pause a minute and let y'all try this one, this number 4. Just get the integral set up. Okay, so here we go. We've got our double integral. Now, it's pretty obvious that we're going to need to fix the y. So I just look for where I can just draw a straight line. Notice from this curve over here, I just draw a straight line. That tells me that I'm going to integrate with respect to x first. In other words, it's horizontal to the x-axis. That's one way you can think about it. And then y is going to go from, what is that, -2 to 2? Yeah, so -2 to 2. And then, so that's what the y is going to go, right? We just say, okay, it's the horizontal line that goes directly across. Okay, therefore, that's what I'm going to integrate with respect to first. And then the question is, well, what does y do? Well, y goes from ha to ha, right? -2 to 2. And then we just say, okay, well, so now dy here, and we just say, okay, this is going to be, we've got y equals -x minus 2. That means that x is equal to -2 minus y. Actually, what am I doing? Yeah, no, that's it. That's it, right? No, is that right? Yeah, that's right. Okay, so we've got -2 minus y, and then it goes over to 4 minus y squared. There you have it. And then it's just a matter of, doing the integral here. So let me go ahead and just get that started. we've got x evaluated from -2 minus y to 4 minus y squared dy. And that is going to be -2 to 2. Let's see here, plugging in the 4 minus y squared for x minus the -2 minus y. That's going to be 2 plus y, I believe. Yeah, there it goes. Now, what we want to do is we want to transition, since we've done some practice with these finding the area of a base, the area of a region on a plane. We want to think of that as a base to then talk about a, uh, a volume of a solid. For example, here I've got this plane, and this plane, just look upon this as, the intersection. This plane intersects the first octant at these points. In other words, it intersects at x equals 3, y equals 4, and z equals 5. Okay, so this plane, just think of this plane passing through the first octant, and what we want to do is we want to get the volume. We want to get the volume under that plane above the first octant. That's what we want. Okay, now the first thing I need to do is I need to come up with an equation for that plane. One of the ways that you can come up with an equation for a plane, if you have this situation, in other words, we've got these intercepts, right? We've got the x-intercept, the y-intercept, and the z-intercept. Look at this. Here's a little trick we can use. We can say, well, this is going to be x over 3 plus y over 1, 2, 3, 4 plus z over 5. I think it was 5. 1, 2, 3, 1, 2, 3, 4, 5. Yeah, equals 1. This is one of the ways you can really quickly get the equation for a plane, because look, if y and z are 0, what is the x-intercept? Well, 3. See, you got x over 3 equals 1. See? If you want to get the y-intercept, find where it crosses the y-axis, just let x and z be 0, and you get y over 4 equals 1, or y equals 4. See? So this is a really quick way that you can get an equation for a plane like that. Now, what we want to do then is we're going to have, think about this, we're going to add up all these little rectangles on the xy plane. All the dx's times the dy. dx1 times dy1 plus dx2 times dy2. We're going to add up all of those, and for each one, we're going to multiply it by height, the z, right? So in other words, let's look at this. Here z is equal to 5 times 1 minus x over 3 minus y over 4. I just solved for z there. That's the height. So dig this. We're going to have a double integral, and we're going to have 5 times 1 minus x over 3 minus y over 4. And then that's the height. We're going to have the base, the area of the base, dy dx, or dx dy, whichever way you want to do it. I'll do I'll do dx dy this time. Okay? So you see this? The area of the base times the height. And you can imagine, you've got this little rectangle on the bottom, and then it goes up to be a solid, a rectangular type thing, and it hits this plane up here. And what we're trying to do is get the volume of that. Okay, now our job at this point is to determine the bounds of integration. Okay, so we want the bounds of integration. So here's what I'm going to do. I'm down here on the xy axis. Okay? I'm right down here. Z is 0. So I'm down here, and I've got this. I've got x over 3 plus y over 4 equals 1. See? Z is 0. I just zeroed it out because I'm down here on the plane. Okay? Now, let's see what we've got here. We've got a line that looks like this, right? It crosses here at 4 and up here at 3. No, I got that backwards, didn't I? It crosses here at 3 and up here at 4. Okay? Okay. Now remember, I'm integrating with respect to y last. So let me get that outside integral. And what does y do? Y starts at 0 and it goes to 4, right? See? Goes from 0 to 4. But now I got to figure out what x does. Well, now we take a step back. So now x is equal to this. X is equal to 1 minus y over 4 times 3. That's what x is. Okay, so this up here is going to be 1 minus y over 4 times 3. And it starts at 0. Okay, now let's take a minute and dig what's going on here. No matter, so I'm going to choose a y, and I'm going to go up here, and the question is, well, what does x do? Y is going to go from 0 to 4. In other words, it's y is going all along. Whoops, you can't see it. Here's y. Y is going all along there, and for every step of the way, I'm going to draw something parallel to the x-axis. And the question is, what does that line go to? Well, it starts here and it goes to here. It starts at 0, x is 0, and it goes until it hits 1 minus y over 4 times 3. That's what it does. Okay? Everybody see that? Now, our focus here is not the integration as so much as the setup of it. Okay, so we'll do practice integration of these, but right now I want to get us some practice getting these set up. Okay. Okay, now let's try this one. Now I want to pause a minute and let y'all try to get this one set up. Notice you've got the plane down here, right? When everything's 0, and you've got the z. So just take a minute and try to get this one set up. And when I say this one, I'm talking about this one. This one right there. Okay, now let's think about what we got here. Picture yourself standing anywhere on the XY plane. Okay, so you're in here, you're just standing down here, and you look up. No matter where you are in this plane on the XY axis, you look up and you see 4 minus x squared, right? That's above you, all in here. So that tells you right away that inside here, there's going to be 4 minus x squared. That's the height. See, no matter where you are in there, you look up and you see your ceiling is this 4 minus x squared. Z equals 4 minus x squared. See, it says right here. That's this dome that's above you. Okay? Now, I forget that, and I say, okay, that's the height. Now, I'm just going to be down here on the plane. Okay? So here I go. Here is the x and the y. Now, we've got this line that's x plus y equals 4. Okay. Now that's just if you notice that's not exactly what we have here, but that's what x plus y equals 4. But that's not what we're looking at here. X stops at 2, doesn't it? See? 2. So let me do this. So here is 1, 2, 3, 4 over there. Now at 2, we get this situation, right? There's what it looks like down on the XY axis. You see this now at this point, I feel like I'm overcomplicating this because notice that this right here is this right here. And then we've got um, this right here is this. You'll see that? And of course, this right here is this right here. Okay, now look, so I may have overcomplicated this a little bit because it's not as bad as you know as you might think. Notice, let me go ahead and erase this. Okay, so let's think. We got to integrate with respect to x or y first. What do you think would be easier, x or y? I'm going to fix one of them, and I need a straight shot to the other. Yeah, it looks like if I fix x, look at this. If I fix x, I got a straight shot. Ah, that's what I'm talking about. So I'm going to have x to go from 0 to 2, and then y is going to go from 0 to what? 4 minus x. You see that? So this is dy dx. Yeah, that's the ticket right there. Okay, everybody see that? Now remember, right now we're just setting them up. Okay, because if we take time to integrate, that just takes time away from the complicated part, which is, you know, what everyone has trouble with. Okay, any questions about those two? Okay. Now, let's look at this one. This one right here. Now, when you first start this, you say, okay, what is my height? Well, my height here is going to be 6 minus x, right? You can just look and see, okay, they've labeled that for me. That's a good thing they've done for me. So now I've got 6 minus x. Good, got that done. Now I don't care about the height anymore. All I care about now is the base down here. And I've got a base that is, whoops, let me draw this a little differently. I've got the first octant, and it looks like this is just going to be, it's going to look like this, isn't it? So this right here is x, and this is y. And the way I drew it, let me do a better job of drawing that. Okay, so this is 2, and this over here is 4. Okay. Okay. And of course, this is x is equal to 4 minus y squared. So it seems obvious that, I mean, the way this is defined, x equals 4 minus y squared, seems like I'm going to integrate with respect to x first, because I'm just going to go from 0 to 4 minus y squared. Since it's in terms of y, I'll have my integration to be with respect to x. So that means that I'm going to select I'm going to fix y, and then I'll just integrate with respect to, well, I'll fix y, and I go from 0 over to 4 minus y squared, like this, okay? And y is going to go from 0 to 2. And there you have it. Okay, okay, let's try this next one. Try to set this one up. So you picture yourself inside this thing and you look up. There is only one roof. It's this this surface here that is z equals the square root of 25 minus x squared minus y squared. See, I just went ahead and solved for z. Now, that is your height. So now you have a start. You've got 25 minus x squared minus y squared. And you can do dx dy or dy dx, it doesn't matter. But think of this as the width times the length times the width times the height. Think of it that way. Okay. Now I'm integrating with respect to x first, so I'm going to just step back here and say, okay, what is y doing? So if I fix y for all these values for y, I'm just coming across here and hitting this thing. And in fact, y is going from 0 to 4. Okay. I got into where I do the outside one first. As far as x goes, well, x now, no matter what, if I choose a y, it's going to start at 0 and it's going to go to 4 minus y, like that. See? Just solving this. Just looking at that little triangular region down there. Okay? Any questions about this cool stuff here? Everybody see? Now, what we want to do then is you want to get your book, and we'll look at page 983, and I want to look at 19 through 24 on page 983, 19 through 24. And I'll go through and work through some of the even ones so you can check your work, but you have the odd ones you can check in the back. Okay, I'm going to go ahead and work through this 20s just so that we can you can check this even one. The good thing about this problem is that the base is rectangular. And that's awesome for us because the bounds are going to be well behaved. In other words, there's none of this slanting stuff where, as y changes, the distance you go is dependent upon x. No, you've got a nice rectangular base down there. And if you're in rectangular coordinates, that's lovely. Because what we have then is we have our height, which is 6 minus 2y. Okay. And then just this rectangular base. So if you look down here at your base, you've got, you've got something that looks like this. So no matter what x is, no matter how you fix x, you're just going up to 4 on the y. So we could say, well, x is going to go from 0 to 2, or actually, I think I got that backwards. I did get it backwards. X is going to go from 0 to 4, and y is going to go from 0 to 2. See, there's none of this y goes from 0 to 4 minus x or any of that because you've just got a nice rectangular base. So this is dy dx. I didn't have to do dy dx. I could have done dx dy, but this is the way I chose to set this one up. You would get the same result if you would integrate it with respect to x first. The difference is the antiderivative with respect to x would be 6x minus 2xy. See? So if you got the antiderivative of 6 minus 2y with respect to x, 6x minus 2xy, because there's no y in there. But the way I did it here, I've got 0 to 4, 6y minus 2/3, well, just y squared, isn't it? And I'm going from 0 to 2 dx. Yeah. So this is a lovely problem because we're dealing with a rectangular base and then just a plane. What could be better than that? And this is not a square. It's just, let me, that looks confusing. Yeah, there, like that. So if I go ahead and evaluate this, I've got 0 to 4, and if I put in a 2, I've got 12 minus 4 dx, which is 0 to 4 of 8 dx, which is 8x from 0 to 4, which is 32. So let me know if I get something differs from you, because maybe I messed up. Okay, any questions about that? Now, if we did it the other way, if we integrate it with respect to x first, that would be okay. We would just have x goes from 0 to 2, and then y goes from 0 to 4, and we would have 6 minus 2y. But now we're integrating with respect to x and then y. So if we did it that way, we would have 0 to 2, and then we would have 6x minus 2xy from 0 to 4 dy. So I'll do it both ways here. Okay. Now let's go ahead and put those values in there. So here, whoops, here we go. Okay, here we go. 0 to 2. Now, if I put in a 4 for x, I get 24 minus 8y. I've got dy. Okay. Now let's see what we get here. We get 24y minus 4y squared from 0 to 2. And that's going to be 48 minus 16. What's that going to be? 32? Hot dog. Man, I was hoping that would come out the same. Because if it didn't, I would have messed up. Okay. Do y'all see? So you can go any order that you want, either order that you would like. On this 22, you notice that we have one roof, and I solved for z to get that. Okay. So it's 1/4 12 minus 2x minus 3y. Okay. So that's my height. No matter where I'm standing in there, if I look up, that's the roof I see. That's the ceiling. Okay. Now I say, okay, z is 0 now, and I'm right down on the xy plane. Okay. So here's the x, and here's the y. Okay. And I just sketch this line by finding the intercepts. Let x be 0, found y. Let y be 0, found x. And I have a choice. I can integrate either with respect to x or y, whatever you fancy. I think I'll go x first here. That means y, I think about y is going to go from 0 to 1, 2, 3, 4. 0 to 4. So I come in here, and no matter how I choose y, I go straight across, and I hit this line. I just hit that line. So I go from 0 to, I got to solve for y, or x that is. X is 12 minus 2x over 3. 12 minus, not 2x, 12 minus 3y over 2. Because I'm integrating with respect to x. Yeah, and that's your setup right there. That's it. That's your setup. Okay. Now, so notice the y's are fixed. 1, 2, they go from 0 to 4, and then x goes from 0 to 6. But really, x is going from 0 to that line. Okay. So lock this in your mind. If you had a rectangular region down here, both of these would just go to numbers, 0 to 5 or 0 to 4, whatever. But the fact that you've got this slanted line here, that means as you fix y, you're not going to the same thing every time. You're going to this line over here, and that line needs to be in terms of y. X equals 12 minus 3y over 2. And the reason it's in terms of y is because you're integrating with respect to x. You don't want to integrate with respect to x and have x in your bounds. That wouldn't be good. Okay. Okay, now, so we got to figure out how to deal with this. So let me work through this. We got, and I'll take a minute to 12 minus 3y over 2. And down here, I've got 3 minus 2/3, not 2/3. What am I doing? Erase that. 3 minus 1/2 x minus 3/4 y. And I'm integrating with respect to x first, and then with respect to y. Make sure I did it right. 12 divided by 4 is 3. Yeah, yeah. There it goes. Perfect. Okay, now here I go. I'm rewriting this integral, and I've got 3x minus 1/4 x squared minus 3/4 xy. And I'm going from 0 to, let me just do this, 6 minus 3/2 y. I don't know if that's going to be better, but yeah, there's what I have. 1/2 x squared. Oh, for this one? Well, I had 1/2 x, so then I divided by 2 and I got 1/4. Yeah. Do you see that? See, this one was 1/2 x, and then when I anti-differentiate it, I got 1/4 x squared because the 1/2 was already there. Okay. Now, now I need to plug in every place I have an x, I need to put in a 6 minus 3/2 y. Okay, so let's see how this is going to look. Okay, so This seems daunting, right? But here we go. 3 times 6 minus 3 halves y, minus 1/4 6 minus 3 halves y squared, minus 3/4 6 minus 3 halves y times y dy. Okay. Now, fortunately, we don't have to do the plug in the 0 because that would just be 0. So normally we would plug in that top bound, subtract off plugging in the bottom bound. But fortunately, that would just zero everything out. So we've got enough problems just dealing with this. So we'll just leave it here. Now, I don't know which way you would like to approach this. I think what I'm just going to do is multiply everything out. Okay. You could do some factoring. I'm just going to multiply everything out. Maybe I'm crazy, but I think that's going to be just a really straightforward way to do it. So I'm going to get 18 minus 9 halves y. Okay, that's that first one. Minus 1/4. Here we got 36. And then, now look, 2 times the product, 6 times 3 halves. That's going to be 9, right? So that's -9, that's -18. And then plus 9/4 y squared. Okay. Now, did I do that right? I took the first term, squared it. Then I did 2 times the product of the first and the second term. Well, the product, 6 times 3 halves is, well, I've got -9. Yeah, so that's right. Okay, then over here we've got minus, okay, 3/4 times 6. Well, that's going to be 9 halves, right? 9 halves y. Now, correct me if I'm not so good at this stuff in my head, but so correct me if I mess up. 3/4. So this is going to be 3 halves. Yeah, I think that's right. And then plus, okay, here we go. This is going to be 9/8 y squared. Really? Huh. Okay. dy. There's what we've got. Now, seriously, let me know if I mess up. 'Cause I'm just a mortal person here. Okay. Now, we're getting ready to integrate, so now I need to see if I can add like terms and what have you. So let's see what I get now. I get 0 to 4. Oh, let's see here. Okay, I've got minus 18 minus 12. See, here's 18, and here is, no, 18 minus 9. So that's 9. Okay, got that right. Now, let's see here. I've got -9 halves y and another 9 halves y. Okay, so that's 18 halves, -18 halves y. So that's -9y, isn't it? And then plus this y over here, and that's going to be 2 will go into, that's going to be 9 halves. That right? And then we've got -9/16 y squared plus 9/8 y squared. Now, is that everything? Now, I realize there's more work to do with this, but yeah, I think we're at a good place here. Okay, now, now it would not surprise me a bit if I'm messed up somehow in my, arithmetic here. So watch me closely now. So here we got 9. Feel pretty good about that. Now we've got let's add the y's. We've got negative 18. So this would be negative 9 halves y, isn't it? And then we've got plus 9 sixteenths y squared. Is that right? I think so. Because if I add these two, I get, you know, 18 sixteenths minus 9 sixteenths. Okay, now, okay, now finally we're at a place we can integrate. This has been a long journey. This has been a long journey. Okay, 9y minus 9 fourths y squared plus 3 sixteenths y cubed. And I'm going from 0 to 4. Is that right? Uh, yeah, I think so. Okay, all righty. Now, all I have to do, one thing, I have to put in a 4. And then maybe a miracle will have happened and I got it right. So 9 times 4 minus 9 fourths times 4 squared, ooh, plus 3 sixteenths times 4 cubed. Okay, I like all these 4s that are going to cancel. That's nice. It's always nice. So this is 9 times 4 minus 9 times 4. Oh, really? Look at that. Those are going to go away. 9 times 4. Okay, good, good, excellent. Plus, is this going to be 3 times 4? Yeah, I think so. I think so. I think we get a 12. 12. Hot dog. That turned out nicely. Makes me think I did it right.